Good morning. It's a pleasure to be here from the peaceful Seattle area to give you an overview of Windows Media 4.0. What I'm going to do is sort of drill down to one more level than Anthony did, but of course leave plenty of room for the rest of the speakers to dive down to the lowest level detail that you'd like. So this is still going to be an overview, but a little bit more about the architecture and what makes the system great. The other thing I'm going to point out is actually the highlights of the system, what makes it great, what makes it good. And of course, audio video presentations are boring without demos, so we'll do a few demos also. Most of you are probably familiar with different uses of streaming media, but the key thing to look at is that each domain actually has a different set of requirements. Music and radio, of course, number one determining factor is the quality of the experience. If you don't have good audio and video, nobody cares about your sort of music and radio applications. And then when you get into business applications there, you want to be communicating information. It's not as important to have your video look the greatest. Looking at a picture of me for 10 minutes is not very important, but conveying other kinds of information, metadata, PowerPoint slides, and other kinds of things are becoming very, very important. In user entertainment, there is being able to do live encoding, real-time encoding, so that you don't have to have a delay between when the material is available on broadcasting becomes very key. And of course, when you archive this stuff, being able to serve those up later on as video on demand is also important. And commerce and advertising is the heart of this technology when it comes to making money. You have to have an angle. At the end of the day, this is all interesting technology, but if there's no money in it, people won't spend any money deploying it. So if you look at the system, there are really three components to it. On the right-hand side is the obvious component, which is playback. This is what all the consumers have, and the largest volume of the applications out there is the players, whether it's a PC or an appliance. All the way to the left is the authoring side. That's where the content gets created using different methods, whether it's real time, where it's coming from a camera or some other broadcast feed, or if it's coming from a CD or some other store format. Once you get your content created, then you have to serve that up. Now, traditionally, people don't think that you need a server to serve up media, but one of the great things a server can do is that it can control the data rate and behavior of the system, so you can manage your network more properly and present a better experience to the user. Indeed, it's not a necessity that you have a server in the middle, but having one really, really helps the overall system. Now, being an internet age, you don't want to have just a dedicated black box server. You also want to use the web server to its fullest extent. And the great thing about a web server is a very programmable API and infrastructure for you. So using the web server and the streaming media server combined, you can have a full control of what the user sees, how they interact with your site, and how they view the content. If you look at the Windows Media 4.0 and broadly the sort of the three categories that I'll be focusing on, number one is best user experience. If you don't have good audio and video technology, nobody cares about the rest of your system. That's ultimately what the user sees. They don't see any of the other infrastructure issues. They don't see the bandwidth switching. They don't see networking. They don't see any of the other stuff. All the user sees is audio and video. And if you don't have good quality, they'll pass you up and go to the next one. And of course, we feel that we have very good technology there. And I'll talk about more details on it. The other thing that's important is to be able to let the user pick their player and the application that they want to play the content on. It's great to be promoting our own stuff, and we do a fair amount of that, of course. But at the end of the day, users may have a different choice of applications they want to use to view audio video material, and you want to give them that choice. And also in this day and age, you want to give them an option of downloading high-quality files to play back locally or streaming in real time. There are drawbacks and advantages to each system, but you want to have an integrated solution that does both. Not one solution that is needed for downloading content and another solution for streaming. That will drive your users and also content producers mad because they have to learn two completely different systems. We have a unified architecture for both purposes. Now, the other thing you want to have, as I mentioned, is other features for the commerce aspects of this for making money. And there is automatic insertion of advertising, much of what you get on television and radio today. Conditional access to streams, so that people have to enter passwords to be able to access them. That way you can pre-sell the event, and at the time the event starts, you can authenticate the users. And finally, rights management for download and play. If the user is going to download content and you no longer have a control on a per stream basis, you must have some kind of authentication and transaction system for when they download the content. And finally, all of this has to make sense. If you have $1 million server, very few people will be able to make a living off of this technology. You have to have a cost-effective system that is not only low cost in software, but also in amount of hardware and bandwidth that it requires to serve up. And it has to have the scalability just in case, and then hopefully when your business succeeds and takes off like Anthony showed on that graph, you want to be prepared to be able to scale up very, very rapidly. So you want to have good performance to start, but also have the story as your needs grow. And indeed, we think we have all of those features also. Now, let's talk about the audio video compression. On audio, uncompressed CD quality audio is 1.4 megabits per second. That saturates a 1T1 link just for one user. Needless to say, you're not going to be able to stay in business long if you want to serve up that stream, and it fills up the hard disk pretty fast. 1.4 megabits per second translated the other way means about 50 to 70 megabytes per 3 to 4 minute clip on your hard disk. Users don't want to download a 50 to 60 megabyte file. They don't want to keep it on their hard disk. Even with today's hard disk, you're not going to be left with much storage if you have a few hundred songs uncompressed. So the standard trick, of course, is to compress these signals. And when you go down to modem data rates of 20 to 30 kilobits per second from 1.4 megabits per second, you're talking orders of magnitude here in compression. And the ear is actually a very sensitive instrument. You can pick up very minute artifacts, much more sensitive than your eyes. And as a result, doing a good job at this has been very difficult traditionally. But you can look at existing technologies out there until about a year ago. When you went out and listened to any kind of music with your modem, you weren't exactly getting a hi-fi experience. You were getting something that was a little bit better than AM quality. And really wasn't what customers wanted. Customers went out there for news sites and information sites, and that was adequate, but nobody listened to music that way as part of their enjoyment. And we set out to really change that game. We wanted to produce something that had to be almost twice as good as what was available at that time to get what we call FM stereo to modem users. So if you have a decent modem, we wanted to simulate what we call digital FM quality. What you listen to in FM is what you want to get without all the multipath and static that you get with FM when you drive around in your car. Now, once you go to download and play, you can actually take liberties with bit rates and go up a little bit higher bit rate than an analog modem that streams in real time. And there, the standard has been MP3 at 128 kilobits per second. MP3 at 128 kilobits per second is not a bad experience. The only problem is that a typical song is about 4 to 5 megabytes. That doesn't sound like a lot of space on your hard disk, but it takes a long time to download with a 28K modem. And also, when you try to put it in a portable music player where you're buying basically silicon storage, non-volatile storage, there's a fair amount of money involved in that. It's much more expensive than your hard disk. And as a result, there's not much space available on those devices. As Anthony mentioned, in 32 megabytes of flash EEPROM that you get on a music player, you only get 30 minutes of MP3 at 128. So there we wanted to preserve the CD quality, but lower the bit rate as much as we could, and we think we've succeeded at getting CD quality or near CD quality at just 64 kilobits per second, so roughly half the size. Now, I manage our audio video compression group, and one of the standard techniques we can use to get better quality in audio video codecs is to use infinite amount of CPU. Give me a CPU that's 10 times faster than a Pentium 3, and I can do a lot better than I can today. But the problem with that is that nobody wants to wait for a 5-minute song to compress in 20 minutes or 30 minutes, or even 5 minutes. People can buy 5x, 10x, 20x, 40x CD-ROMs, and they want you to keep up with it. It's not acceptable to go out there and encode at 1x or 2x, which is all you need for streaming. You just need to be fast in real time. And indeed, we didn't want to make that compromise. So Windows Video Audio is extremely fast, about 20 times faster than the TwinVQ Roadster that we used to ship in our last release. And part of the speed comes from clever algorithms, and part of it comes from optimizations we've performed for various processors. We use WMS features, which are available on all the Pentium CPUs and Cyrix and AMD processors. And we also use up to 2 CPUs in parallel, in addition to Pentium 3 SSD optimizations. So all of that put together translates to very, very fast performance. We'll be able to keep up with the fastest CD when you're ripping your own music. And of course, if you're a content producer and you have 500,000 titles that you want to encode, this is a fast system, and the dual processors let you go twice as fast. We've had about 40, 50 million copies of our player downloaded. Many of these players were downloaded before this codec was developed. Fortunately, that player, all of our players that we've shipped, the Windows Media players, have automatic codec upgrade capability. If the user ever goes and clicks on a link that uses a codec that the player does not have on the system, it will query a special server at marcus.codec.markshop.com and fetches a copy of that codec and automatically installs it and plays it. And indeed, the Windows Video Audio is only a 75 kilobyte download. So in about 30, 40 seconds, even on a 28K modem connection, the codec is downloaded and the user can play. Now, since we've made this technology available in April, just about, I would say, majority of these users have already downloaded this codec. So it's not an issue, but just give you a feel for sort of future-proofing the user experience, is that we are able to upgrade the technology as we need, and the player automatically adapts. So at this point, let me get into a demo and introduce Brooks Cutter, who's one of the experts in our deployment team. So just give you a feel for the quality difference. And of course, bear in mind that this is not a sound system that you want to be listening to audio demos, and all of these are available on our website and sound booth that we do at the show, so you can listen for yourself. But just to give you a feel for it here, if you haven't heard it. Oops.
Well, today we wanted to just really sort of go through our audio demonstration and give you an idea of what the quality sounds like and how we do compare with the competition. First, I'm going to run through a couple different sound clips and give you an idea of what we sound like at streaming speeds at 20 kilobits per second, very typical for users on a dial-up modem. And we've actually selected 2 different music clips. I'm going to play you the same clip 3 times. First, I'm going to play you the original uncompressed audio, what it sounds like coming off of the CD, so you can sound what the original pure sound is like. Then we took Real's G2 product and basically used all the templates to compress this at 20 kilobits per second in stereo. I'll play you the Real version. And then Windows Media 4.0, what the capabilities are of the new Windows Media Audio codec. So first, here's the original raw uncompressed file. Then compress with Real's G2 at 20 kilobits per second. And then Windows Media. So as you can hear, there's really a tremendous difference. It's really quite amazing. At that low data rate, we're able to preserve so much of the original quality of the audio. In fact, the big difference between the Real and Windows Media format is the richness of the sound. Windows Media has much more of the highs, and it's much more pleasing to the ear. The reason why is because we've actually done a lot of work to compress and handle the highs of the music without introducing any degradation of the audio or artifacts. Typically, that's very difficult to do in audio compression, and we've solved that problem, resulting in much better sounding audio quality. I'm going to play you another clip here as well, which is perhaps a little bit less classical, and to give you an idea of perhaps more modern audio, what that sounds like with the codec as well. Here's Pretty Boy Floyd, again, the uncompressed audio. Then Real G2 at 20 kilobits. And then Windows Media. So you can really hear the difference. It's reasons like this, the great audio quality, that today we have over 1,000 radio stations online streaming in the Windows Media format, and we're finding many of them are switching over very quickly as they hear for themselves just how much richer Windows Media sounds. Now, at the same time, this is also a great solution for downloadable music as well. As you're probably well aware, MP3 and other formats have become very popular over the past few years for people to download digital music from the web and listen to it on their system. Well, Windows Media Audio provides a superior solution to MP3 because the audio compression is so good that's equivalent audio quality at half the file size. Again, I'll play you a few clips to go and compare it with MP3 so you can hear for yourself. Here's an Everlast tune. First, I'll play you the raw, uncompressed file as it came off the CD. And then we compress this into the MP3 format at 128 kilobits per second, which is what's required for CD quality sound. Here's MP3 at 128 kilobits per second. And now Windows Media at half the size. So as you can hear, Windows Media is the best audio compression for streaming on below dial-up modems with the richest audio, and it's a superior solution to MP3 for both the smaller size and also the digital rights protection as well. Thank you.
So we can switch back. Great. So the key thing to notice here is the file sizes here. I mean, the original short clip is 1.7 megabytes per second, and MP3 is 156K. And the 64K WMS Windows Media Audio that you listened to was only 82K bytes. These are actual file sizes. You can, again, download these things from our website, and I'll give you a pointer at the end, and listen to them on your own home stereos. So technically, let's give you a little bit of data. Codecs are very hard to describe in sort of straightforward speeds and feeds because they deal with psychoacoustics models of your ear and human hearing system to handle compression. But there are some specs you can look at when you compare codecs, at least as first-order data before you do listening tests. And that is, what is the bandwidth or frequency response that you get out of the codec? If you look at the CD, the frequency response of the CD is about 22 kilohertz. You have human hearing roughly ends about 20 kilohertz, although as you get older, you can't hear 20 kilohertz that well. But you're born at least with this ability, and CD is just a hair above the best hearing system, although some people argue whether that's the case or not. But anyway, from frequency response point of view, that's true. And then if you look at different technologies when encoding in stereo, how much of that bandwidth they preserve, or frequency response they preserve at 20, 32, and 64K, you see a picture that looks like this. MP3 actually lands at last position. At 20 kilobit stereo, it only preserves about 2.5 kilohertz out of the 20. So needless to say, if you listen to anything at 20K, we did real networks demos, which are these guys in the middle. We've done MP3, which sounds very, very awful and horrible. So to be fair with MP3 guys and not make their life too miserable, we don't do 20K demos. But feel free to do those comparisons. You'll see that MP3 is really not usable at low bit rate. A lot of people go around and talk about streaming MP3s and what a great experience that is. But of course, it's streamed on a 28K MP3s, which most people can't listen to. If you stream the data rates that everybody else can listen to, and you get very, very low quality. If you look at the real networks G2, this is what you heard, and Windows Media Audio, you can see that we have almost double the frequency response here, and that's what you really heard. There were a lot more highs in there than what real networks G2 produces, and there's no two ways around it. No audio in stereo at 20 kbps on G2 is ever going to have more than 5 kilohertz response, which is what you get in AM radio. It's just impossible for it to produce more than that. It filters all the highs before it encodes. Now, as you go to a little bit more decent bit rates, 32 kilobits per second, we actually get 16 kilohertz bandwidth, which is just a hair more than what typical FM reception is, which is about 15 kilohertz, or 32 kilohertz sampling for our case. And again, you can look in here, as the bandwidth goes up, of course, the other technologies also scale up with it, but not nearly to the extent that we do. MP3 now achieves AM radio at only 5 kilohertz, and G2 is struggling at half the rate that we have at 32 kilobits per second. And then once you achieve 64 kilobits per second, we're at full 44 kilohertz sampling or 22 kilohertz flat frequency response. G2 is achieving FM radio, and MP3 is still at half the CD rate at 12 kilohertz. So 11 kilohertz. So it's still not CD quality. That's why most people will not encode in 64K MP3. It just doesn't have the quality that they're looking for, and they always go to 128K for that reason. And note that even on 128K, if I plotted that where these charts do achieve the numbers that we have, MP3 rolls off to high frequencies above 17 kilohertz, regardless of the bit rate. So listen to MP3s on a high quality system and compare it to original, you will always have some of the highs missing. But we don't do that even at 64K. So oftentimes we do comparisons against 128K MP3. People say we actually sound better at 64K because we have a flatter frequency response. So this just gives you sort of speeds and feeds for the codec and why we sound better. So that's audio. Audio is great for radio and music, of course, but people like to have that visual experience to go with their audio. And here we've had a great standard that we've been working with, which is MPEG-4. MPEG-4 is a successor to MPEG-1 and MPEG-2 efforts of ISO and MPEG committee to basically produce a codec that has no limits. MPEG-1 was designed for original CD-ROMs at 1.2 megabits per second and higher. That was the goal, was to get video on a CD. That was the #1 goal. There was no internet 10 years ago, and there was internet, but most people didn't know it existed. So the MPEG efforts weren't focused there. MPEG-2 was designed from 3 to now 20 megabits per second high definition television for full resolution TV. MPEG-1 is half resolution. And as a result, none of those technologies scale down to modem rates or typical broadband rates of a few hundred kilobits per second. And MPEG-4 was designed to solve that problem. It scales from just a few kilobits per second all the way up to as high as your system can handle. It really has no limitations. And in our system, we support up to 10 megabits per second, and the lowest bound is actually can be as low as you want, but 10 kilobits is probably as low as you get on a 28K modem. And it has no limitation. Again, the technology is very optimized. Now, we've done a lot of work with MPEG-4. We're one of the early members of the committee that defined the MPEG-4 standard, and we've been very active. We provide one of the reference implementations of MPEG-4 that we put in public domain. And as a result, we have the most optimized implementation from both quality point of view and performance point of view. But a quality point of view, we'll do some demos in a couple of minutes, and you'll see that. You've seen the earlier demos of it in Anthony Bay's presentation. And clearly, this is a technology that has good performance at any bit rate that you pick. But on the hardware side and the resource side, again, we could have used lots of CPU cycles to produce our quality, but we didn't do that. Again, the algorithm itself is rather efficient, but most of the speed that we get, it comes from super optimizations of this codec on multiple processors. We can use as many as 4 simultaneous processors to speed up the encoding. We used optimizations for AMD-K7. We use optimizations for Pentium 3, the SSE instructions, and of course, if you have an old Pentium system, we use MMX instruction sets out of that. And all of that combines to give you very, very fast performance. Compare, for example, to QuickTime Sorensen codec. This is about 20 to 30 times faster encoding. So what could take 1 minute to encode in our technology would take half hour. And QuickTime's audio codec is about 3 to 5 times slower than our audio codec. So combine the two together, we can encode a 3-minute music video in 2 or 3 minutes, whereas the equivalent one on QuickTime could take 2 to 5 hours. So performance comes back to haunt you if you don't have it, and indeed we have that both on audio and video. Now, when you're encoding a content, oftentimes you don't know the user's bandwidth, and they could come from a corporate network, probably that has no limits up to all the way to T1, for example, or they're coming from a modem, and what do you know about the modem connection rate? You don't know. A 28K modem may connect at 48K, may connect at 26, 22, 24. A 56K modem could connect at any data rate that it wants from 56K on down. So we've added the ability to do what we call intelligent streaming, which lets you take up to 6 different bandwidths, you get to pick what they are, and combine those into one streaming file. And the beauty of this system is that when the client connects to the server, it actually knows the data rate that it has and discovers the optimal bandwidth to play and starts playing at that rate. Now, even if your bandwidth drops in the middle of that transmission, it will actually adapt to that, and if it speeds up, it will actually go up. So it's like gears in your car, it will switch up and down. Other people will advertise the same system, but they force the user to select their bit rate. And how would a user of a 56K modem pick their data rate? They can't. What if you have a machine that has a 56K modem that you use on the road, and you bring it to the corporate campus to hook up with the internet? Do you want to see 56K clips? No. Again, this system not only allows you to have all of these streams in one file, but the client and the server dynamically negotiate to pick the best bandwidth initially and also as the clip plays. So again, let me invite Brooks back up to show you a video demonstration.
Well, what we're going to demonstrate is actually play you a video clip at a couple different data rates so you can get an idea of what the quality of our MPEG-4 codec is. First, I'll play you a video from 28, and then we'll go all the way up to 300 kilobits to give you an idea from narrowband to broadband quality. First, here's the video at 28. Playing, you know, with 28, there's not a lot of bandwidth there, but we still have a very decent picture. You're typically looking at about 5 to 7 frames per second, and the picture is pretty sharp, so you can definitely get an idea as far as what the quality looks like. Now, when we talk about 28 as well, we're really streaming this at 20 kilobits per second. The reason for that is we want to make sure there's plenty of room for maybe a modem that doesn't get a solid connection at the high data rate, or perhaps you're loading web pages simultaneously with the video as well. But as you'd expect, also, as we increase the data rate, the video quality goes up. We get a higher frame rate, a sharper picture, and better audio quality as well. Let's try a 56 kilobit version of this video. So again, the picture size is improving, the frame rate is improving. At this point, we're about 10 to 12 frames per second. It's still a very good picture for considering its size and the bandwidth. At 56K, we're actually optimizing this for a 37 kilobit per second connection. Again, very infrequently do people get a solid 56K connection, and there may be other traffic going across, email or web or other data as well. Now, 100K is where we get a very sharp picture, and we start to approach at least, we hit at 15 frames per second or even 30 frames per second with some content. And this is a data rate very common for corporate environments where there may be streaming across a LAN, or perhaps for ISDN as well. Let's look at the 100 kilobit per second video. Not too bad. It's a lot better than what we saw at the modem rates. It's still a bit grainy, but I mean, actually, it's a great picture at this point, which you can definitely watch for quite a while, and this is great for people using it internally on their intranet. Now, at 300K, this is where we get into the broadband space. This is where people will be watching with cable modems or DSL modems from home, or maybe even over a T1 at their workplace. And this is where we start to get to a new level. We can achieve full-screen video that starts to rival the television as far as the quality. At 300K, we're encoding this at 320 by 240, the same window size, but we do achieve 30 frames per second for nice, smooth motion. I'll go ahead and play the 300 kilobit video and then put it into full screen mode. So you can see the 300 kilobit video. One of the great things is that in this case, we're taking a video and actually resizing it 2 to 3 times its original size. But you don't see blockiness, you don't see degradation in the video. That's some of the great things about MPEG-4, that it handles the scaling very gracefully and provides a great full-screen video. Thanks.
One of the things I want to, my mic now? One of the things I want to point out also on the video is that the audio codec actually helps make the video codec look better. So how is that possible? Because we're twice as efficient as the other technologies, you can allocate half as much bandwidth to the audio and leave the rest of the bandwidth for video. Like in this 300K, what users actually want is CD quality audio. And if it allocated 128K for MP3 or real J2 codec, you would only have 200K left for video. We can do this at 64K or 48K and still preserve majority of the CD quality and the bandwidth and allocate the rest of it for video. Same with 28K videos and 56K videos. That's one of the reasons also the video looks good. And the sample material that you saw was actually typical material. We could take a talking head news and show you that. But music video that has a lot of transitions, a lot of difficult clips in it, is a demo that we're showing you to actually show you real-life test cases for what would be a music video. Now, I've mentioned Windows Media Player. We have about 50 million of these things downloaded. This is part of almost all Microsoft products moving forward. It's really going to be available on every machine, so you don't have the issue of worrying about whether the user has this player or not. Users will have multiple media players, and ours will be one of them, and it's on their desktop. And the player, the nice thing about Windows Media Player is that it does a lot of things. It's not just a specialized player for one thing, for streaming or for download. It plays many, many different formats, many different file formats, everything from MPEG 2 to MPEG 1 to downloaded music clips to MP3 to our own format. So it's really a universal player. It can be embedded in Netscape or IE web pages. So it is really a full function media player. Now, that's all great, and we love for people to use our player, but at the same time, we're also a platform company, and we work with many third parties to build players. And we have an SDK, which I'll talk about, which easily in one afternoon allows any of these players to support our format. And indeed, we've worked with them to do exactly that. So in early days, we've worked with Winamp, who's now owned by AOL, and Sonic, that got bought by Yahoo, I believe. And Music Mag Jukebox, Sonic Foundry Siren. All of those music applications will be able to play our audio format, and Music Mag Jukebox actually recently announced that they can actually play video also in addition to audio. And that's a key thing. We're not trying to force you or the consumers into one solution. If they have their favorite music application that's Winamp and they want to listen to radio stations that we have on our format, great, let them do that. We're not trying to twist people's arms to use our player with our advertisement in there. So, as Anthony said, PC is great, but you want to be able to take your music and video with you sometime. You don't want to be stuck with just having it on the PC. PC is great, but you don't have it in your pocket when you're sitting on the airplane. So we're having a very aggressive effort also to port our format and technology to many, many other appliances, everything from the smallest, tiniest music player to more sophisticated devices such as the Casio PDA. And Brooks will do a quick demo of that if you haven't seen it before.
Yeah, so what I'd like to demonstrate actually is on the Elmo here, the overhead projector. We actually have a Casio E100, which is a Windows CE-based palm-sized PC that allows you to download things like web pages or applications or contacts and calendaring. And also included on here is something called the mobile audio player, which allows you to download Windows Media audio content and be able to play it on this device. Or you can take other formats like MP3 and convert it into a format as well. But in this case, I've downloaded a number of different audio clips to the device, and I'll go ahead and play you a few off of this device so you can hear what it sounds like.
You're listening to the Mobile Audio Player.
This was playlist.
So we have a couple different tunes that are on there that you can actually hear and see what they sound like. Now this device itself actually does have stereo headphone ports, and we have a little buzz in there. But I can actually store up to 4 hours of music on this device with expandable memory as well and take it with me, maybe play it on a plane or somewhere else as well. Now also we're seeing that Windows Media is being supported not just in portable devices for playback, but also for content creation as well. Here I have an example of a video camera, actually a digital video camera from Sharp called the Internet View Cam. And this particular device will actually capture content directly into the Windows Media format. So I can shoot a video and onto the memory card, transfer it down to my PC, and I can then play it with the media player or stream it with the Windows Media services as well. So we're seeing more and more examples of these types of devices capable of playing content, creating it, and making Windows Media available everywhere at any time.
Great, thanks for that. Aside from this camera uses MPEG-4, and it was independently developed by Sharp as far as implementation of MPEG-4, but they use ASF, which is our file format, to integrate audio and video together. And you pull out this memory card, as Brooks mentioned, and plug it into a PC, and double-click on a file, the player plays it, you can put it on a server and instantly serve it up. So there's no dead time between taking content from a camera getting it to a PC and wanted to encode it and wait for that compression to happen. This is instant streaming. When we're working on our digital audio compression, we're quite concerned that the copyright owners and music labels would be very upset with us because they were already unhappy with MP3, which allowed music files to become 1/10 their size, and then they were easy to distribute and give away legally or illegally to people. And any technology that made that twice as bad, if you can think about it that way, since the files are half the size, would not be a necessarily good thing in the eyes of the content owners because it made it that much easier to send the bits around and bypass the rights of the owners. So we came up with a technology that's optional. You don't have to use this. It sits on the side of the audio-video compression technology. And it allows you to encrypt your content and tie it to a specific device or a PC. And once you do that, of course, you have the basis of a copyright management system because once the file is logged to a PC, then you can control, how people pay for it. They can't just give away copies of it to their friends. And the basis of this technology is that the content is encrypted and you acquire a license, and really like a ticket to go to see a movie that allows you to experience the music or video in this case. And that's a key thing. This technology is not bound to the audio codec. It's not part of the audio technology. It's actually the technology that applies on any multimedia file that you have in our ASF format. It doesn't care if it has audio. It doesn't care if it has video. It doesn't care if you have URL flips in it or other multimedia content. It encrypts the entire file and protects it with device management. The key thing about this technology is that it gives a tool to content owners to either get more revenues from their stream or get a better user base, a mailing list, or whatever they want to do. There's no policies implied in this technology. It's not designed to collect money from people. It's simply designed as a tool for content owners to apply any policy they want to their content. I'll give you a little bit more details in a minute, but this technology, of course, is part of the Windows Media Player 4.0, but it's also more importantly available part of our SDK. When an application vendor uses our audio-video SDK and builds their player out of it, they automatically get the ability to play encrypted digital rights management content also. They don't actually have to do anything special. They don't even know that their player is actually playing encrypted content. All of it happens behind the scenes transparently to them. And as a result, they don't have to understand any of this hard technology. All they got to do is use the simplest they can. In one day, they can play both protected and unprotected content. And indeed, as I mentioned before, this SDK has been used by Winamp and all the other guys that I talked about, and I'll come back to that in a second. So let me walk through the sort of workflow of how the system works. On the left-hand side is your digital content, which you must already compress using our tools or third-party tools. So once you have your unprotected content that you can play anywhere, then you run it through what we call a packager tool. This is a web-based application that you go in there and basically import your data. And once you give it the multimedia ASF file, it will then encrypt that content. Once the file is encrypted, you can then do whatever you want to do with that file. You can give it away to your friends. You can put it on CDs. You can bundle it with new PCs. You saw an example of it on the Play Pack where we put it on every CD. You don't have to make any decisions at that time as to how much people have to pay for it or what rights there are with that file. Simply give away the file. The file itself can be distributed any way you want. You can distribute it using any web server, FTP server, Unix server, any kind of server you want. Again, it doesn't matter how you get the file to the end user. You can, of course, put it also on the Windows Media Server, and if you put it on our server, you actually get a secure transmission scheme where your on-demand files are actually authenticated and encrypted. But assuming that you just want to download this file as a non-streaming application, the file just gets placed on the user's PC, however you can get it out there. Now, once you have the file and the user double-clicks on it to play it, the media player or any of the other third-party players wake up and look at the content, and they look at the header, and they say, wow, this is encrypted content, and they look for a license file. And, of course, the first time somebody gives you a piece of content, there is no license to play this file. And the player then looks inside this package that comes with the encrypted file, and there's a URL in there, a secure URL that tells you where to go acquire that license. The player simply hands that URL off to the browser, and the browser pops open whatever web page that he sees at that point. Now, we call whoever handled the license issuing the clearinghouse, And Clearinghouse is really a web server initially that gets this request and this URL and presents the user with the policy decisions. The policy decisions are, you're going to charge a buck for each song, or you're going to give it to them in exchange for their email name, or whatever else you want to do, or nothing. You could just give away all your music if you like. But the nice thing is that they come back to you and you get to track them. They come visit your site at least once, and you can decide what you want to do. Again, we just don't define any policy whatsoever regarding this. We just send the user to their web page, and the web page can say anything it wants. It can advertise, it can show banners, it can track the users, it can query whatever it wants. But when you're all said and done, you collect whatever information you want to collect. You then call a COM object that we've written that runs in Windows NT Server that, given a specific song and given a special ID that we generate for the user's system, we'll be able to issue a specific license that's peculiar and only usable on that user's PC. And the license file is about 200 bytes or so, and it gets downloaded and it gets put on the user's PC. Now, if the user takes that, once they have the license file, the media then starts playing. Then they can play it as many times as they want, and they no longer need an internet connection or a connection to the outside world. The media will play forever. If that's the rights that they put in there, users can, the content owner can optionally put time limits on them, as we've shown you on the media pack. But that's only up to the content owner. Now, the user might think they're clever and they take this little license file and give it to their friends, but as I mentioned, the license file is tied to the user's PC. It's peculiar and specific to the user's identification of, user's PC identification. And if you take this license and give it to somebody else, nothing bad will happen. There's no warning come out and say you stole this file. The player simply ignores the license file and goes back to the same web page again. It says, welcome, here's a license. Now, if the user loses this license file, the clearinghouse can keep track of the users, and if you go back the second time, they say, oh, welcome back, we lost your license, here's another copy of it. But that's, again, totally up to them to implement all these features. We're just a software company providing all the software components. Now, you saw an earlier demo of Launch already, so I won't bore you with another demo. Suffice it to say that Launch is providing this, one of the sites is providing downloadable digital rights management content. And the key thing here is that when you go click on these links, there's a preview and then there's a download link. Both of these use an identical same system for encoding, compression, and everything. You don't have to have a streaming preview in Real G2 and a downloadable file in Liquid Audio. With our system, you encode your file at 2 different bit rates, and you got the same thing. You got a preview and you got the final one. You can use the same application, same workflow, same encoding process, and create both your previews at lower bit rates and download files at a higher bit rate. You don't have to use 5 different systems. The second thing to know is that there's no transaction cost. We don't get paid for every one of these downloads. Other competing systems give away the player and encoders, but they charge you 1%, 2%, 5% of your transaction costs. That might be a great model for them one day to make money, but content owners don't like to pay you, especially not today when the market is young and there isn't a lot of money to be had. Indeed, many times they want to give away the songs just to get you to come to their side. So we don't charge any transaction fees on the back end. All we ask you is, of course, to buy our Windows platform, which for the license acquisition is a Windows NT server. Once you have an NT server, you'll be able to issue licenses, but of course the client is a Windows platform. So that was downloadable and digital rights management. For general streaming content and also for downloadable music, we have a music directory we call windowsmedia.com. Unlike other portals that you've seen out there, we actually host no content whatsoever on this site. Well, what makes it great then? What makes it great is that it's a very, very popular site. We promote this very, very heavily, and we collect a lot of users who come to this site looking for content in Windows Media format. When you download IE5 and click on Radio Garden, we'll give you demos in a second, it takes you to this site. Now, what we do from this site is that we link to our partner content. And anybody who encodes in our format can get listed in here, and there's an online submission form. You simply fill out the form, tell us what your content is, and give us a URL, and we'll publicize it for you. There's no cost to you at all for this feature. As a free promotion for you, we fund all the cost of running this site and promoting it and everything. It's 100% benefit to you with no competition. We're not trying to compete with you as a service provider or content provider. Again, the site itself has no content. When somebody clicks on the link, it literally goes to your site, and it's your site that's presenting the user whatever you want, with your banner ads or commercials or whatever you want, tracking We're not trying to host your page inside our page and trap the users or anything. This is all to promote the technology and our partner solution. Now, the other key thing is that it's great to have all the stuff in English, but for local markets, we're also customizing this. We've had a very successful site in Japan that's becoming very, very popular also with sort of music revolution taking off over there for downloading music and also streaming. And Australia also just recently started, and there are a lot more countries to come. And again, just to emphasize, this is free promotion for you. The only thing we ask for is that the URL that you give us points to our content. If it doesn't point to our content, it won't get listed. But otherwise, there's no cost to you. So again, Brooks, if you can do a quick demo of this would be great.
I wanted to go just take a moment to show you the WindowsMedia.com website. And if you actually go out to the web at www.windowsmedia.com, you'll actually be able to access the content guide where you'll find audio and video content online. You can promote your site here and listen to radio or download different types of music as well. Let's try that again here. So at WindowsMedia.com, you'll find a couple different sections. For example, there is a radio bar, a music section, and also downloadable content as well. There's about 1,000 different clips today. Yeah, it looks like we're having a bit of a challenge here. But this is a great site that you can actually find lots of content online as well today. And as Amir mentioned, it's free. You can go online and actually post the information about your clips.
Again, if you're just going to remember one word, is WindowsMedia.com. Just go out there and all the content's there. You can play with it yourself and all sort of different categories. And then the highlights that you see, of course, were top content when top 10 music on the charts becomes available as a streaming or download content. Of course, we promote it very highly on the front page. But regardless of the importance of the content, we will promote it and categorize it. And it's just really one-stop shopping for end users to just go in one place and find all the content that's compatible with their system. So we can switch back again. Now, if you look at the return on investment on a streaming system, it's really a combination of different components. How much does it cost to encode? How much does it cost to serve up? What bandwidth costs do you have? And how much support calls you're going to get? How reliable is the system? And how many streams you can support? And key things to look at over here, we have many customers that host multiple formats. And invariably, they come back and tell us that our system is far more scalable and reliable than other vendors. To give you an example, a dual P2450 can serve up 4,000 20K or 28K modem streams. That's 80 megabits per second, roughly 2 T3 links with a simple dual processor, $3,000-$4,000 machine with RAID 0 disk subsystem. And this is with NT4. You can expect with Windows 2000 to actually get a lot more streams than this. And of course, if you go faster than the P2450, you'll get even far more streams, and we support up to 4 processors, so you can get as many streams as you want. And of course, the technology is very easy to scale up by having more PCs too, so you don't think that you have to keep adding processors. You can cluster 5 or 6 machines. But just right out the chute, with a single processor, you can get nearly 2,000 streams, which again saturates the T3 leg. And you don't need to buy a whole bunch of hardware, a whole bunch of expensive machines that you have to maintain. And the key thing is the uptime here. Very hard to advertise uptime. I can't just really charge some figures like I do with the other ones. It's really what our customers tell us and what their experience is that we really, really test our software. This is not something we quickly install new features and release them every 3 days with beta 1, 2, 3, 4, 5, 6. We really, really test this stuff because we understand transmission is really mission critical. How many times do you see your NBC station going out there? You don't see that very often, right? Same over here. If this is your transmission scheme, you want to make sure that it's very, very reliable. And the features that also go with this as far as reducing your cost is multicasting if you have a corporation. On the internet, that's not a practicality, but on a corporation, turning on your routers to support multitasking is pretty easy. Once you do that, that solves all your bandwidth problems, because if you have 1 or 10,000 users, all of them share one stream, and you don't have to keep paying your added costs. And as far as the cost of the system, as most of you probably know, the server is an integrated part of Windows NT Server. Once you get an NT Server, you have a license for unlimited streaming, so you no longer have to go out there and keep licensing additional modules. None of the features that I talked about is optional. You don't have to go get a commerce edition for authentication or internet edition for something else. Everything that I talked about, or Anthony showed you earlier, as far as adding search and everything, is all features of the same server, one package, one part of Windows NT Server, and does everything that we talked about. And on the encoding side, the tools are part of Windows or Windows NT, your choice which one you want to use, and of course the player runs everywhere. And the rights manager, as I mentioned, is part of Windows NT Server, and again, it's a great tool to let you collect additional revenues for your content. Now, if you do corporate webcasting, we have an internal view tool that we use at Microsoft that we developed. It's a combination of HTML, MVV, and other technologies that basically integrate a calendar where everybody in our company can go out there and look at what's on today. They sort of get a calendar over here, and they can click on all these links over here. Then they see all the events over here, and then the details of them on the right-hand side. Now, you say, well, that's a great system for you guys. Why do you tell me about it? Well, we give away this as a sample application. It's available on our website and also our Jumpstart CD, and let you build your own basically system from very, very quickly that lets your employees instantly know what's on. And it's got nice administration interfaces so you can add content, people can submit things to you and query what's on and everything. Very useful thing. Again, it's just available as a sample application. It's all sources, of course, you can modify it whatever in whichever way you like. I've mentioned SDKs a couple of times. We are a platform company. We like to build great applications ourselves, but at the same time, we want to give tools to everybody to do the same thing. So we have SDKs for everything. We have SDKs for audio and video, so you can build your own encoding applications, which build your own playback applications. Both our server and encoder, and of course the player also have interfaces so you can host these things in other applications and control their behaviors. The player, as I mentioned, the SDK can be used embedded in a page, whether it's Netscape or IE, doesn't matter, and control, you can start and stop it and that sort of thing. And again, the Format SDK, which is in beta right now, supports full audio and video compression, so you can build your own player and your own editing application that encodes and edits our format. Totally available. There are no special entry prices for these things. You don't have to sign up to come into developer to get any of this stuff. You can go download all of them free of charge from our site today and start building the application as fast as you like. The SDK interfaces are designed to be very simple. These are not complicated things that take you years and years. As I mentioned, the audio SDK, you can use in 2 hours to build an audio player. Literally 1 or 2 hours that any junior programmer can integrate it. Anthony went through the list of partners, so I won't go through that. Jumpstart CD is a great thing to get. I think it's, when you finish today, you get one, or you may already be in your folders. I don't remember which. But this is available free of charge again, and it has lots of the demos in here, the cool demos that you've seen, and you can actually look at the sources to see how they were done. Very clever demo of Mick Fleetwood, where you watch through a basically virtual set that's streamed, and very, very clever. And you can look at the techniques that we used in there and how you can do your own tutorials. Lots of this software, so you don't have to download them from the web. It's just on the CD, and you can use it. Highly recommend that you look at this, and lots of white papers and how-to articles. So if you're going to remember one word again, it's Windows Media. Look at Microsoft.com/Windows Media, and everything is there. You can see the player there, the server, the tools, SDK. Just click download, and all the software is there for you. So with that, we can take, I guess, do you want to take up questions? Yeah, if you have any questions, again, there will be drill downs later on, and you can ask experts all the detailed questions that you like.